In the previous video, we completed the online operation of the DU03L. Next, we will configure the submodules behind the DU03L and program a running lights display. First, we need to configure the submodules. Right-click on the DU03L here, select Add Protocol, choose Odot here, and click Confirm. Here, you can see I/O device. Select the I/O device, right-click, and choose Add I/O device. When entering for the first time, there are no submodules. We need to import the XML file for the submodules. Drag and drop the file here. This completes the addition. Then, here we can find our submodules. What we are actually configuring are two DT222F modules and one DT5800 terminal module. We add them twice here and add one DT5800 terminal module. After the addition is complete, our submodules can be seen here. Then, at this point, after we have completed the addition, we select Deploy Configuration. It will show deployment successful here. After completion, we proceed to the next step to look at the process data of the DT222F. It is a 16-point digital output, so it has 4 bytes, which are QB0, QB1. Here it is QB2, QB3. Next, we only need to assign values to these addresses to complete the running lights display. Next, we return to the application. On the right sidebar, there are system function blocks and some custom function blocks. For this demonstration, we will use custom function blocks to write the running lights program. Select this custom function block. Click New Function Block and name the project Flash LED. As for the type of function block, it includes simple function block, basic function block, composite function block, and service function block. The simple function block is a simplified version of the basic function block. For this demonstration, we will focus on the basic function block. Click OK. The function block is created. Double-click to enter it. IEC 61499 operates on an event-triggered model. So we need to establish events first and also establish variables. We establish events first. To establish events, we create 2 inputs first and similarly create 2 outputs. One set of events we will use for initialization. And after the initialization is complete, we need to output an event. Here, after initialization, we need to execute the running lights periodically. We need a request event. Here, there is a completion event. These are the events. We need to establish a variable. Since we are creating running lights to make the program execute periodically, we only need one output. For the output, since it is 4 bytes, we create an array of 4 bytes. Here, click OK. This establishes our variable. Then for the variable, we also need to associate it with the events so that its data updates when the events complete. So we click here to make the association. This completes it. Then next, we need to write its algorithm. Here we can add algorithms. We need to add an initialization algorithm and an algorithm for the periodic execution of the running lights. First, we add an initialization algorithm. Then here, the program can be written in ST, ladder diagram, or C language. For this demonstration, we will use click OK. This is an initialization program. The initialization program can be referenced from our manual. The system manual has a program like this below. We copy this program directly. Paste the code directly here. Then we create another program algorithm for the periodic execution of the running lights. We then copy the program from here. This completes the program. Let's save it. Next, we need to associate the program with the events. We need to enter its ECC state machine. Here, there is a start state. Later, we can add different states and different operations. We have 2 states, so we need to add 2. One is the initialization state. The event it triggers is this initialization event. After triggering, it needs to execute the initialization algorithm, which is this algorithm. After executing the algorithm, we also need to output an event, outputting the initialization completion event. After this is done, we need to return to the start interface. We need to execute the periodic running lights. We need to add a second event. This algorithm is triggered by the request event. After triggering, we also need to execute the running lights algorithm and output this completion event. After completion, we also need to return to start, so it can execute cyclically. At this step, we have completed the encapsulation of the function block. Let's save it. It has completed the encapsulation of events, variables, algorithms, and the state diagram. After completion, we return to this custom function block. Then select Compile here. You can see a prompt indicating successful compilation. This function block is now written. Next, we return to the application to call it. Call this function block. Drag and drop directly. You can see the function block appears. After it appears, we need to pair it with some system function blocks to make it run. First, we need to add an event to allow the program to execute periodically to create a running lights effect. Select Event. There is a general event here. Then there is a cyclic event period here. This period, we can set it to start when the initialization is complete. We plan the time to execute with a 1-second period to execute such a request. This request will be given to our backplane task, AIOSYS, given here, will be passed to our I/O devices. Triggering in this way refreshes the output data. We have completed the wiring for such a simple program. We need to map the program into our controller. If there are multiple controllers, we can map different function blocks to different controllers to form distributed control. Here we have only one controller, so we map everything into it. Here you can see all the programs have come over. After they come over, we have a control start event here. We connect this event to the initialization. When it starts, the program completes initialization and then proceeds with periodic execution. This completes the program. Next, we need to bind it to variables. Let's save it first. To bind variables, we switch to lEC addresses in the top right corner. Then, enter the actual DU03L module addresses here. You can view them here. Starting from 0 with 4 bytes. After completion, click Save. You can see it has been saved successfully. Next, we download the program. To download, click on DU03, select Deploy. Click Deploy. This shows successful deployment. The program is downloaded. We select the program for monitoring. You can see the program executing periodically. After initialization completes once, it executes periodically every 1 second. Then we click on DT222F, select Online Monitoring. Here you can see its data also changes every second, achieving the running lights effect. We can see the module's LED lights are operating as expected. This concludes our demonstration.